guys, hope you're doing well. Today is gonna be our first lesson on this online platform. So, as we have been talking for the last 2 weeks about matrices and determinants, we will do some review before the exams. In this lesson, we will talk about the definitions of matrices, how we do operations of matrices, and type of matrices. First of all, how we can define a matrix. A matrix is a rectangular array of numbers. These numbers enclosed by a pair of brackets. So we call each one of these numbers an element. So each one of these two matrices has some elements. Could be 2 multiplied by 3, could be 3 by 3. But why do we need these matrices? Let's take a look at this system of equations. We have this system of two equations, x plus y equals 7 and 3x minus y equals 5. Normally we have some ways to solve this system of equations because it's only two equations. But how about solving a system of equations with 4 equations? This would take a lot of time. That's why we need matrices which can help us solving these equations. Okay, take a look at this examples. A equals these elements within those brackets. So AIG, we call these elements. So each one of these numbers here, we call this element A11 because the index of this element is 1, 1. This means this element has the first row and the first column. This element has the first row and the second element, and so on. So this matrix consists of m multiplied by n elements. It's called the m multiplied by n matrix, or simply the matrix A if the number of rows and columns are understood from the matrix. Once or whenever we have m equals to n, or the dimension of this matrix is equals, we can define a special matrix which is the square matrices. A is called a square matrix of order n, or n square matrix, when we have the number of lines of columns equals to the number of columns. Based on this definition, we can define a new definition, which is the trace of the matrix. The trace of the matrix A, and we define this by trace of A, is the summation of all these diagonal elements. So to find the trace of a matrix A, we add these diagonal elements until we get the trace of A. Another definition, which is the zero matrix. If every element of the matrix is 0, we can call this matrix a zero matrix. So look at this matrix A equals brackets, and we have all the elements in this matrix are zeros. So to find the trace of this matrix, we can say immediately add these diagonal elements which are zeros. This means the trace of the zero matrix equals to 0. Operations of matrices. The first operation of matrices is sum or addition of two matrices. If we have A defined as a matrix AIG and B is defined as another matrix BIJ with order m multiplied by n, so we can add this A to the matrix B and define the answer, which is C, and each element of this matrix Cij equals to the corresponding elements of A plus the corresponding element of B. Example, If A equals to 1, 2, 3, 0, 1, 4, and B equals to 2, 3, 0, negative 1, 2, 5. The dimension or the order of this matrix is 2 multiplied by 3, and the order of this one is 3 multiplied by 2. So the answer, which is C, equals to, take each one of these elements and add this element to the corresponding element. This would give us the new element of the C. Example, 1 plus 2, this would give us 3, and 2 plus 3 would give us 5. 3 plus 0 is 3, and 0 plus negative 1, negative 1. The same way, if you want to subtract two matrices, you would say A minus B. Take each element of A minus the corresponding element of B. So in this case, we would say 1 minus 2, the answer would be C11. 2 minus 3, the answer would be C12. And 3 minus 0, so the answer would be C23, 1, 3. So to add two matrices or to subtract two matrices, we can note that the order of this matrix should be the same as the order of the other one. So based on this, we can define two matrices of the same order as said to be conformable for addition and subtraction. This means we cannot add or subtract two different matrices with two different orders. So to add or to subtract, we need to have the same order for each one of these matrices. The second important operations of matrices is the scalar multiplication. Scalar multiplications means if we have a number and we want to multiply this number by a matrix, so how would we multiply this number? Let's take an example. Let's lambda be any scalar or any number, and let A be a matrix of an order m multiplied by n. So if we want to multiply this scalar lambda by A, we can immediately take this number or this scalar and multiply this scalar by each element in A. So if A is 1, 2, 3, and 0, 1, 4, and the dimension or the order of this matrix is 3 multiplied by 2, so to evaluate the value of 3, which is in this case the scalar multiplied by the matrix A, we would say 3 multiplied by A, so 3 multiplied by each one of these elements. 3 multiplied by 1, 3 multiplied by 2, 3 multiplied by 3, and so on. So the answer would be the same matrix multiplied by the new scalar. We can notice that the order of this matrix hasn't changed after multiplication by the scalar. And in the special case when lambda equal negative 1 and multiplying this negative 1 by A, we will get negative A. So we call this matrix the negative of A. And if we subtract A minus A, or the addition of the matrix with its negative, we will get the zero matrix. Now let's talk about the properties of these operations. So let's say we have three matrices A, B, and C, and those matrices are conformable. This means they have the same order for addition and subtraction. If A plus B equals to B plus A, why? Because we can use the commutative law. This means the order of the addition is not important, so we can add A to B, which is equals to B plus A. The second property of this operation is the associative property. If we have three matrices and we want to add these three matrices, you can choose any two of them. So in this case, we chose B plus C, or we can choose A plus B. And in either cases, you will get the same answer. The third property is the distributive property. If we have a scalar and we want to multiply this scalar by the addition of A plus B, so we can distribute this lambda over A and B. So lambda multiplied by A plus B equals to lambda multiplied by A plus lambda multiplied by B, where lambda, as we said, is a scalar or a number. So if we want to try to prove these properties, you can use the matrices and an example, and you can prove that you have these properties in each one of these operations. So thank you so much, guys, for listening to this class. We will continue with operations of metrics. Thank you.